Okay, we don't have to do that. This is what case with the even the zero transformation. So there is the okay, there is the some postulates and the logic gates. Okay, some theorems also. Okay, today we will see some more basic simplification of the boolean functions with the postulates and the theorems, boolean theorems. Okay, how to simplify the boolean functions? So let me write one more time to the some boolean theorems and the postulates once again, because few students will often so let me write some binary operations. Okay, there are two types of operations here. Okay, one is what R type or another one is AND type. Okay, these are the dual to each other, one to another, dual to each other. Okay, the duality will come slowly in the replacing the 0 to 1, 1 to 0 and also we will replace the R to AND to R. But here the only the variables will be same as it is. Okay, same as variables will be what here the same. They will not change the variables names, but they will change the duality condition. If you want to get the value of a particular boolean function theorems, okay, we have to change the change the plus to dot to plus. That's the product to plus product, and also the binary value can change it 0 to 1, 1 to 0. Okay, let's write few more theorems. Okay, those theorems will I will write them one more time just to concentrate here. Okay, first one is what here the postulate. Okay, postulates are some assumptions. Okay, assumption if the in the world, okay, something is empty, that is to be what here considered to be what here the that is the 0, that is to be what here 0. If it is something is there, okay, that is to be considered what here the 1. Okay, that's nothing but here the some assumptions are there. Okay, if the bicycle is low, that is to be considered as the binary 0. If the bicycle is high, that is to be considered as the 1. If the switch is okay, but if any one is on, that is to be considered as what here the high, that's the name of the 1. If my 1 is off, that is the name of the 0. Here means what we have the two values for the particular variable. Means what here the one variable can have the two values, either 0 or 1. That's the name of the we are constantly here. We are giving what here the some consideration of what here the some values as the 0 or 1. 0 or 1. The variable can have the two values, that is to be 0 or 1. Some assumption we are making before going to get there with these things. Let me write the some assumptions to any variable can have the two values, either 0 or 1. This is to be some postulate assumption. Okay, some theorems are there here. Some theorems are there. Okay, some postulates are there. Expectation is what here the x plus 0. X plus 0 is what here the x plus 0 is what here the x. Similarly, I will write the some only one side, that is to be binary expression, and also where of that particular operation can also write later. Okay, okay, next one is what here the okay x plus y equal to y plus x also. I can also write and even the commutative, and also then the fourth one is what here the distribution. Okay, x y plus z, and also can also have the x plus x z. Okay, and even I can also write the x plus x dash is what here the x dash x what here the 1. So my variable is having the 1, then the x dash should be what the negative of that. Okay, that's literally this negative of that is what here the 0. Okay, it's equal to 1 only. That's it. But here the I can also write the it's equal to what here the 1 only. Okay, it's equal to x plus x dash is what here the 1. And also by another theorem, some theorems are there. X plus x is what here the x. Some theorem number 1, theorem number 2 is what here the okay, x plus 1 is what here the 1 only. X plus x is 1, x plus 1 is 1. And also theorem number 3 is what here the x double dash. Okay, this is the complement of the particular function value variable is what here the same as the other postal value. And also theorem number 5 is what the some okay, have already put in the last class, but still I am realizing this. What is the duality? These are some functions. Okay, some here postulate 1, postulate 2, postulate 3, postulate 4. Okay, these are the some postulates. Okay, this is the postulate 1, okay, 2, 3, 4, 5. These are some assumption I made here. As can have the two variables as 0 1, x plus 0 is what will be x only, x plus y is equal to y plus x, and also xy with multiplication with the differential complement law, and also x plus x dash is what will be the 1. Okay, these are the theorems also here. Okay, next we write the dual of these functions. Dual of this function x plus x plus replaced r is replaced with what here the product form. That's the r is replaced. This is the r form. This is the product form. Okay, product form we have the x dot 0 is what here the 0 only. This is what we will put the angular appear values is the what here the x plus 0 is x only. X dot x 0 x only. pastulates and also some theorems, okay, related to the boolean logic, okay, related to the binary functions. We can also simplify. In order to avoid the what is the necessity of the simplification of the boolean function means here we have some engineers they don't have the proper knowledge of the basic gates and all, they don't have some knowledge how to design it. Okay, in such a situation they will be designing the logic gates with the currency. Okay, that's the complex form. In order to work on this complex forms, okay, that's the if my function is what we have the repeated variables, repeated functions, repeated logic gates, that will be what is the cost effective and also will not get the clear of the particular boolean function. Okay, in order to work on this one, we need to simplify the boolean function. Okay, we need to simplify the boolean function. How to get on the simplification of the boolean function? There are two ways. One is what here with the help of the boolean theorems and the postulates. Another one is what k-map is there. Okay, k-map. Okay, boolean function. By using the boolean theorems and postulates, we can simplify up to what here the three variables only. Three variables. We can use these postulates and theorems, these formulas to only up to what here the three variables. Okay, if you want to work on, if you want to simplify the more than the three variables, 4 variables, 5 variables, and also 6 variables, then we go for what is the k-map, karma map. Okay, karma map. Okay, more than the 6 variables we cannot simplify. Okay, that also we can also simplify with the help of the one more is the Green-Mackey method is there. Green-Mackey method. But this is not for your syllabus. This is not for your syllabus. Only up to the k-map is for your syllabus. K-map with the 4 variables. K-map with the 4 variables, not the 5 variables. Even we don't have the syllabus in your syllabus. K-map with only 4 variables. He has not mentioned that for 5 variables and the 6 variables. Okay, we will see that one. But for let me discuss. Okay, let me simplify the some boolean functions which are to be with the help of what the boolean theorems and the postulates. Okay, let me consider the functions here. We have already seen that this simplification of the boolean functions in the last 3 days classes. Let me do some work. Okay, these are the some examples which are the boolean functions which are used in last of the examinations. Okay, A, B are the two variables and also okay, A dash B is there. Okay, A dash B. Okay, A, B dash plus A dash B. Okay, all of the complement of this one and also what is the A plus B. Okay, I want to the time for you to write the one more on whatever I wrote. Okay, whatever I am writing on the board, just even copy it. Yes, sir. I need to write and even taking the notes as possible because whatever I am writing on the board, that is enough for us for writing the examination. Okay, just whatever the things I have written on the board. Even I will teaching 7 days. Okay. Yes, sir. Okay. How to use this one? What type of equation I have here? Okay, this is the boolean function. Okay, use the some postulates theorems are there. Okay, this is what is the x plus y dash is what is the x dash y dash. This is what theorems theorem. Okay, this is what the theorems theorem. Apply this theorems theorem to this particular part of the function. Okay, apply this theorems theorem there. Okay, a dash a b dash plus what a dash b. Okay, if I apply this one x plus y dash is what is x dash dot y dash is there. Okay, similarly I will be writing the time. Consider this as one term here. We have two terms in the one in bracket. So I have two terms. What is what a b complement and a1 and b. Okay, let me write this one is this. Okay, I am using the De Moivre's theorem here. X plus y dash is for y dash is what is the what is the x dash sorry x bar to the y bar x bar dot y bar. So I am using this product here. I have two terms here. Okay, I am using right as this consider as the one variable, this consider the other variable. Okay, then I need to complement of this particular just to put the complement forms on this one. Okay, complement form this one. Okay, one more time to apply the keep as the same as the a plus b as well as c plus b. Okay. Then just write the okay, one more time you apply the okay, I had already taught you in the last class. Okay, in order to simplify the boolean functions, there is a precedence is there. Okay, precedence. Then first I have to go out the parenthesis, then the not yet, another one is called the and the or only. Okay, I have to solve the simplify the boolean functions with the some precedence is there. Because the operator precedence. Okay, that's nothing but the first one is I have to simplify with the parenthesis. Then I have to simplify with not plus the particular parenthesis, and also then I have to go with the and or only. Yes sir? Yes or no? Okay, that's nothing but in the mathematics we will be using the BODMAS rule. Is there no? Bracket BODMAS bracket addition.
What is mean by inverter case?
What is the?
What is mean by inverter case?
You want to come here? Come here. Come here. What you? Inverter. Inverter gate. Okay, I will discuss. Okay, it is asking me to what is the inverter gate. This one is the some boolean logic gates. So we already discussed in the earlier class. That's in the first one also. After already, but I will repeat over the some basics over the after the completion of my regular class. Okay, let me complete this one. Okay, I am using the some theorems here. What is that one? That is the theorem theorem. Okay, apply the theorem theorem for particular one. Okay, see there. Okay, a dash. Okay, b double dash is what the apply the product of the theorem theorem. X dot double dash is what the x dash plus y dash. Yes sir. Apply this one is what the b double dash. Okay, the present is and of a double dash plus b. Okay, let me write a plus b as it is. Okay, this is the okay our form. Okay, this is what the a dash b double dash is what b only. Okay, x complement of the particular x variable is what the same original value only. X complement of the particular variable is the same variable x. X double dash is what x is just use that formula. B double dash is as b and also a double dash is what the a double dash is what the a only and plus b dash plus b dash. Okay, plus b dash. Next is what the a plus b. Yes sir. Okay, then we use the but I can also write this as a dash plus b plus a b dash and also a plus b. Yes sir. Okay, then we get the multiplication in the all these things. Okay, then we write then I have to multiply this. Okay, this is what is the a dash plus b a b dash plus b dash. What is the one? Okay, just write the a dash plus b. Okay, multiply between these two. Okay, it's better. Okay, a dash is what is the a and a is what is the plus ab and also b dash is what is the a dash b dash and also b dash. Okay, apply the rules here. Okay, a dash is x plus x naught x is what is the x dot x what is the x only. Okay, so just use the product of the same variable is what is the same only. Then a plus b a plus ab plus ab dash plus of inverse law. Okay, x dot x value what is the 0 only. 0. Yes sir. 0 only. Okay, I can also write this one is what the other. If as it is what here the a only, and also I can also write the same as ab plus ab dash. Okay. The same thing I can also apply the same as this as the x plus xy equals to x. Okay. But here the not possible. I have to take what here the a dash plus b. Okay, a dash common here. Okay, this will be 1 plus b dash. 1 plus b dash is what here the 1 plus d. Okay, 1 plus b x plus 1 is what here the x only. X plus 1 is what here the x only. So that I can also have 1 plus b any variable is also to be what here the to be what here the 1 only. X plus x dash. Sorry, x plus 1 is what here the 1 only. So that I can also apply this rule as a 1 plus b. This is to be a. This is what here the 1. Okay. This is to be what here the a into a bar plus b. Okay. Just apply one more time here the a dot a bar plus of ab. Okay. Just to apply. This is what a dot a bar is what here the 0 plus ab. Final answer is what here the ab. Final answer is what here ab. If you with the complete full function while implementation of the logic gates, if we simplify the particular function, we get the only one gate is there. What type of gate I can use there? AB. AB means what? The product form. Product form is nothing but what type of gate I can use here? AND gate. AND gate. Okay. AND gate will tell us to it's a product form. Okay. There is nothing but the AB. It's any operator. Operator. What type of operator is there? Dot operator is there. Okay. Dot operator is used for the only the logic gate, which is to be what is the AND gate. If I am using the plus operator, that should be what is the OR gate. What's with the AB? Simplification of the boolean function if you not done, then I need to use the how many gates here? So many gates here. Okay, here you can see here one gate, second gate, third gate, fourth gate, and also fifth gate. Around 5 gates I will be used. If you will simplify the boolean function with the help of the boolean postulation theorem, I can write only with what here the only one gate, that's to be what here the basic gate only. Yeah, otherwise I have to be implement this boolean function with the 5 gates. Okay, you can go. Okay, this can avoid what here the this can avoid using of the logic gates repeated. Okay, logic gates repeat again. Logic gates use for only one gate is for the I can implement this particular boolean function. Okay, simplification of the boolean function. Okay, that's there in our logic gates. Okay, in our boolean logic gates. Okay, I will have some arguments here. Just to simplify the following boolean functions. Write it. Simplify the following boolean functions. Following boolean functions. A into a plus b. A into a plus b. There are still the examination. A into a plus b. Yes, there are a plus b. Okay. Simplify the following boolean functions. Okay, just to take up the function of boolean function a into a plus b. We simplify this one, and the second one is what is the a plus b